Hi guys, Dr. B here. So today we are going to go over atomic theory, the history behind it, and you're going to be expected to know what these people contributed, maybe how they contributed, etc. So the first one is Democritus, the first person we're going to cover. And he was a Greek philosopher, lived in ancient times, so obviously he won't have like the same type of tools or technology that the other ones will have. But he theorized that matter is made up of tiny indivisible spheres called atoms. Okay, so he's the one who gave us the term atom. And so this is what he looks like. And so yes, kind of true, kind of not true, just depends on the test I got, but you know what I'm trying to say. So however, John Dalton comes along several years later and says, hold on, wait a minute. And what he does, he actually bases his theory on two laws, the law of conservation of mass and of constant composition. Conservation of mass, that law says that matter is not created or destroyed in a closed system. And constant composition says that a pure compound will always have the same proportion of the same elements. So he comes up with 5 different postulates based on these. Elements are made up of small particles called atoms. Atoms of a given element are all identical. Atoms of different elements are different. Atoms cannot be subdivided, created, or destroyed. Atoms of different elements combine in whole number ratios to form compounds, meaning you can't have half an element or 0.25 of an element, if you will. And in chemical reactions, atoms are combined, separated, or rearranged. Notice how his elements on the side kind of resemble sort of resemble at least the shapes you all did, your elements, compounds, mixture of compounds, etc. So J.J. Thomson comes along and says, wait, there's more again. So he discovered the electron in 1897. He used something called a cathode ray tube to measure the mass of particles in cathode rays. A cathode ray tube is a sealed glass tube in which air has been evacuated, and a high voltage is applied, which causes a beam of particles to flow from the negative charged electrode or the cathode to the positively charged or the anode. These tubes are called cathode ray tubes because the particle beam or cathode ray originates at the cathode. This ray can be detected by painting a material known as phosphors, which I can talk about later in terms of glow-in-the-dark stuff, if you will like. So the phosphors spark or emit light when impacted by the cathode ray because they are absorbing light and then they absorb and then they release light in the form of energy, or energy in the form of light. I had it backwards. So this is a diagram of what it looks like. When we're in class, I'll show you a video detailing this. So to test the properties of the particles, what he eventually, in his test, what he found was that the cathode ray was deflected away from the negatively charged electrical plate and towards the positively charged plate. This told him that the cathode ray was composed of negatively charged particles, electrons. The mass turned out to be smaller than the mass of hydrogen, which was known at the time. So that means that there was something smaller than hydrogen, than an element in these particles. So Thomson also came up with something called the plum pudding model. He knew that atoms had an overall neutral charge, therefore there must be a source of positive charge within the atom to counterbalance the negative electrons, negative charged things. This led to Thomson proposing that atoms could be described as negative particles floating within a soup of positive charge. Sounds kind of gross. This is called the plum pudding model because, I guess, according to English people, it looks like something called plum pudding. That's what it looks like. I don't think so. I think it looks like a cookie more than anything, but whatever. To each his own, I guess. So which of Dalton's postulates did this invalidate? When you read these, the 5 of them, Thomson found that there's something smaller than an atom. So of these 3, he invalidated the fact that the postulate that atoms cannot be created or destroyed. or subdivided. That's the main part, the subdivided part, because he subdivided. He found something smaller than uh, than the mass of the smallest atom. So there must be something else in there. So then someone else comes along again, Ernest Rutherford, and he goes, "Wait, there's more. I swear." What Rutherford did was he discovered the atomic nucleus. He shot alpha particles, which was a type of radiation, at these thin sheets of gold foil. To his surprise, some of the particles ended up bouncing back. So he knew that alpha particles are positive. So for them to bounce right back indicates that they bounced off of something that was also positively charged. So that means scattered throughout these sheets of gold foil, there was something positively charged. Because he knew that, well, if for it to be detected somewhere else, for it to be bounced off somewhere else, if he noticed that, so what happens, I'll say it this way, there's a detecting screen that he had around the gold foil. So for the most part, it shot right through and went past on the other side. However, there's a detector on this side, on the opposite side right here, from here and here. The fact that something bounced off of that to go a different direction indicates there was something somewhere in the foil that was positively charged, so it deflected off of that. And also all around here too, because if it was just going to go right through, if there was nothing positively charged in the gold foil, it would have just gone right through, no problem. However, because some of them were bouncing off and hitting at different angles, it meant that it was bouncing off of something positive within the gold foil itself. And we're going to hopefully be able to do a demonstration of this in class. Niels Bohr, what he did was he put it all together. So he created, quote unquote, the Bohr model. He took Rutherford's discovery of the nucleus and combined it with some other research. And what he said in his model was that the nucleus is at the center, which had protons and neutrons, and which is a nucleus, and the electrons are orbiting it. So hopefully you should kind of recognize this from one of your assignments, the POGIL. So remember that when electrons are quote unquote like going from different orbits, if they go from here to here, they have to absorb energy to get away from the attraction to the nucleus. And then once eventually it gets released, it goes down, it's an orbit level, and energy or light is released. Also in your notes, please include that James Chadwick discovered neutrons. All right, guys, so that was the end of our lecture. We will discuss this when we come into class. If you have any questions, let me know. If not, I'll see you then. Bye, guys.